Thank you for watching this presentation of MakeCap Power, XNets and TPoints. This is part 1, focusing on XNets in the Capture Constraint Manager flow using MakeCap Power's Enhanced Flow option. You can import Constraint Manager and TPoint data directly from your PCB editor binary BRD file into MakeCap Power using its enhanced flow. This will make your Capture desktop with MakeCap Power Constraint Manager aware. These are paths that you can create in PCB Editor that use series components to connect 2 or more nets into one overall path. XNet paths are frequently used in order to define timing between any 2 points on the XNet path. A very common type of XNet are series terminated nets where a resistor connects 2 nets between a driver and a receiver. Another type of XNet that's frequently found are high-speed gigabit differential interfaces that use series capacitors to connect 2 differential pairs. When PCB Editor creates XNets, it will always name the XNet with one of the names of the subnets in the XNet. You can choose to have the other net in the XNet the name of the XNet, but you cannot create your own name. The XNets that have been defined in PCB Editor are visible due to the enhanced flow in MakeCap Power, and you'll see a column here called XNet. And we can sort that column by simply toggling the header. I'll do it a second time and scroll down to where it starts alphabetically. And I'm going to highlight the 2 XNet entries called B and C2. And you can see the 2 nets that are in B and C2, one of which is B and C2, and the other which is out A, because PCB Editor always uses one of the subnets in the XNet to name the XNet. Now if I mouse over, I can get information about the XNet, and if I go over to the icon next to name, I can get a list of explicitly what the 2 nets are that are in there without having to do a sort based on the XNet name. When defining pin pairs across an XNet, Constraint Manager will not allow you to define a pin pair that includes the body length of the series component. MakeCap Power will also prevent this. MakeCap Power uses Visualize to help you visualize how the XNets are organized and what pin pairs you can legally create across the XNets. So let's open up min-max propagation delay screen. And let's go into Enhanced Pin Pair Display since we know these are XNets. They're displayed here also as XNets. And now we're going to get a conceptual representation of the 2 subnets that are in these XNets and the series resistors that can join them. So we can see in here these are the resistors, that this is net N14855, this is net VD0, and this is the XNet called VD0. Now if I want to make a pin pair starting from C16, I can make a pin pair to any of the other pins in the XNet path except the pin that's on the other side of the series component, because the length of the series component cannot be used to create a pin pair. So it is voided out for you within the Visualize display. So if I want to make a pin pair from C16 pin 1 to U1 pin J4, I'll just click it, and now I've got an XNet pin pair going from one net to the other net across the series component. When working with net level values such as width, in an XNet all the subnets must have the same value as the overall XNet, which is the only path now. This is called bubble up. The bubble up rule for XNets means that for net level properties, every subnet in the XNet must have the same exact net level value so that the XNet has just one net level value. Let's take a look at XNet VD3. If we mouse over it and data mine it, we'll see the other net in here is N14843. So I'm going to give an impedance rule to VD3 net, and I'm going to call this 100 ohms, and I'll give it a 5 ohm tolerance. There's our rule. And now if we go back and look at the other net that's in this XNet, in 14843, we'll see that make cap power automatically makes sure that all net level values that you enter on any subnet in the XNet flows out and bubbles up to all the subnets in the XNet, so that when the XNet is shown in Constraint Manager, it has one consistent value across all of its subnets and its own listing.